Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, if you look at the top or the bottom of your screen, wherever your Zoom controls are, you should see a little button that says Q&A. Click on that. You'll be able to type in your question, hit submit, and I'll get to those at the end of the session. If you're joining us on YouTube, just find the live chat function wherever it is on the machine that you're using and type in your question there, and I'll go over those at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, I was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. And before that, it was 8 years at Subaru. So worked at a Subaru dealership, and over time just became the diagnostic guy in the shop. So always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is VVT operation and testing. So we'll talk about the different variable valve timing systems being used on vehicles today. There's a few different types. Go over the different components, how we're going to test it. Then we're actually going to walk through a quote unquote live case study on the tool, walking through a real life scenario that we ran into one time. So first off, we'll start with some different terms that we're going to use. So we have VVT and VVL. So VVT is variable valve timing, and that advances or retards timing using the cam gears. So some form of an actuation on the cam gears is how that operates. And then we have variable valve lift. So that changes valve lift and or duration by using multi-lobe cams. So we can change the amount of lift. We can also change the duration depending on how that lobe on the cam is set up. So first off, we'll go through variable valve timing. So the variable valve timing components. First and foremost, we should talk about the cam gear. So it is the tooth gear on the outside, right? So it looks just like a normal cam gear on the outside. It's driven by the belt or the chain, depending on how the vehicle is set up. And of course, the camshaft's connected in the center. So in this case, we have the bolt right there. And it is hydraulically controlled. So if we take a closer look, we have these vanes inside, and this is the hydraulically controlled portion. The outer sprocket stays pretty much where it is. It stays on the belt where it belongs on the belt. And then these vanes are used along with oil pressure and these oil chambers in order to allow oil to fill in. And because of oil pressure, advances or retards the timing. Now, most of the cam gears will have a spring inside that automatically defaults it to a retarded setting that'll hold it kind of back. But we'll see how they operate here in a second. We're going to walk through some animations as to how this would work. The thing that controls the oil is going to be this oil control valve. So this is an electronically operated spool valve. So we can see we got our connector right there. Electricity goes in. We got some coils going around this pintle that moves back and forth and has these different passages. So depending on whether it moves in or moves out is going to depend on how that oil goes through. So if the oil goes through here and it goes out there and it comes back down through there, just depends on how far out or how far in it moves and how these different holes line up. And it'll make a little bit more sense once we get to the actual animation in there. So the spool valve part moves in and out. And then this, some vehicles, especially Subaru for sure, uses this style on their newer chain drive motors that they have, the newer chain drive 4-cylinders that they have. They came out with around 2011. A lot of the valve components are inside the cam gear itself. So this is really just a little rod that pushes out, and it's pulse width modulated. It can control how far out it goes. And when it pushes on the center of the cam gear, it kind of rides in the middle of the cam gear. When it pushes on that cam gear, that's what advances or retards the timing based on how far it pushes. There's a couple other manufacturers that use a similar type system where it actually pushes on the cam gear itself. So those are really the two main oil control methods for that. And then, of course, we have the oil feed lines as well. So usually they're a banjo type bolt with some copper O-rings, copper washers, and then you have your oil feed line. And then, of course, inside, we're going to talk more about this in a little bit, but there is a filter in there as well that helps filter out the crud that might be inside the oil, and we'll talk about how that can affect it in a little bit. So now that we know the base components, let's talk about how it operates. So in this case, the valve is closed and we don't have any oil flow. The oil just kind of sits there where it's at. In this case, it's kind of at a neutral state on both sides. So we have oil pressure in there, and then it cuts off the oil pressure, so it holds that pressure in there, and it doesn't really go anywhere. So it can hold it at a steady state. It can hold it advanced, retarded. If there's no oil pressure, then it defaults all the way back to full retarded, but it can hold it at whatever set amount of degrees advance or retard that it wants, based on how that valve is open and closed and how much pressure is on either side. So let's look at advancing the cam. So the spool valve in this case slides out. Oil comes in down here at the bottom. That's my oil feed, this light blue. And then the oil goes through the chamber out onto this side. There's more oil on one side than the other side, more oil pressure, so it moves the vanes to the right, moves the cam. And then on the lower pressure side, that drains out and goes back, of course, into the oiling system right there. So depending on how these spool valve moves, depends on where that oil pressure goes. So we notice the oil goes in the middle and then it comes out either side. And if we go the other way, we're going to retard the cam. It's going to pull the valve out the other way. Oil still goes in the middle, but this time it goes into the other chamber because of how this valve moved. And then the oil will drain out the other side. So we have increased pressure on one side, not the other. And that's what holds it back in the other direction. So it just kind of moves back and forth. Let's go backwards again. So there's my advance. We have higher pressure on one side. And then the retard, we have higher pressure on the other side in that direction. So it just depends on where the pressure is at. And it's a hydraulically actuated gear in that case. And it's kind of an oversimplification of how it works, but that's at its base, that's how it works. So now let's talk about the other side of that, variable valve lift, because some vehicles have just variable valve timing. Some vehicles have just variable valve lift, and some vehicles have both. So we'll talk, it's kind of important, and they go together. So it all starts really with the camshafts on these vehicles. And I'm going to use the most famous variable valve lift system in the world for this example, because they have really good pictures is the main reason. But on the VTEC system on Hondas, right? Way back in the Fast and Furious days that came out and changed the way that we think about small displacement engines and how they can operate. So for variable valve lift, and it's pretty much across the board, this is how it works. It's going to have multi-lobes on the cam. So in this case, we have a higher lobe in the middle, and then we have these lower lobes on the outside. Here's a little bit more detail right here. So the middle lobe has a higher lift, and then the low lift lobes are on the outside. So this really comes down to the rockers. The rocker system, how that works is we have our primary and secondary rocker arms on the outside, and those will ride on those low lift cams. In the middle, we have the medium rocker arm in here, and that rides on the high lift cam. And then in between the three, it also rides on a metal shaft that goes through this area right here with these washers. So it goes through there, and using oil pressure, it can push these pins out. So these pins sit inside the rockers. When it pushes the pin through, it locks the three rocker arms in place, and then it follows that high lift cam because the other outside rockers are mechanically now attached to the center, and those are the ones that open the valve using a oil control valve. So this is basically a spool valve like we were talking about on the variable valve timing, except it uses for variable valve lift. So it can change open and close, changes the oil going through the different passages through that rocker shaft. In this case, this has a control solenoid, and it also has a pressure switch for diagnostic purposes on there as well. So it knows if the pressure is low, the computer will know. And they call that the VTEC solenoid. You may have heard people call it, but it's really just an oil control valve there. And then to see how this works, so here's my low cam setting. As I said before, it just kind of rides on those lower cams on the outside. Notice how the pins line up. So there's a gap there and there's a gap there, and they just kind of ride on the outside as they normally would to open and close the valve. And notice how the valve is pushed closed with a spring. So the oil just kind of makes a loop here, doesn't really do it. Then when we need it to ride on the middle cam, the valve opens up, pushes the oil in through the rocker shaft over to the one side, pushes against that return spring. The oil pressure causes the pins to slide against that return spring, locks them together mechanically. You see there's no longer a gap there. And then now it's forced to ride on that higher cam, which gives us higher lift. And we can also, if the manufacturer wanted to, they could change the duration as well. And you can really hear it depending on the car, depending on how the intake system is set up. So I used to have this Acura Integra GSR 94. Loved that car. It was a great little, fast little rocket coupe, as it were, but had VTEC, had the VTEC engine in it. And as soon as you got to a certain RPM and a certain load, you could really hear that open up, and you could hear it start pushing more air in through the intake. So you could definitely hear it on there. And just because it's changing the amount of airflow in the engine. So that allows the manufacturer to get a better performance envelope out of a smaller package engine. And then we also have BMW. Now BMW, as you may be aware, they tend to like to over-engineer things, I think, in my opinion. So let's just make it super duper complicated, because our engineers are really smart, and we'll just figure out a way to do this, right? So they have this system in there called Valvetronic, and it uses electric motor to change the amount of lift on the cams in this way. So instead of using mechanical and oil, we use electronics, hence the Valvetronics. So it uses this electric motor, stepper motor with a worm gear, and that worm gear rides on this like half moon gear here, which turns an eccentric shaft. You can see how we have the curve changes as that eccentric shaft rotates. Then we have the rocker here, which pushes on another rocker down here, which then opens the valve. So this can go from no lift to max lift and anywhere in between. So in this case, it's fully closed. That camshaft just rides, and this arm does not push down on that valve whatsoever. And then if we push out, rotate that sprocket around, and now you can see how it pushes more on that rocker. And then as it pushes, it's going to open that valve a lot more. So it varies, like I said, from no lift at all to maximum lift, whatever the engineers programmed in there using that eccentric shaft pushing on this other rocker arm there. Now I have an animation that'll show you what it looks like. So here is eccentric shaft closed, very little lift. All the way has no lift. And then we have normal, and then we have max. So you can see there's max lift there when it pushes that eccentric shaft around. So all it does is rotate this shaft either way. And like I said, it's variable, can vary from nothing to max. And then here's my camshaft over here, and you can kind of see how that works. So it's one motor that turns a whole shaft. So it's not like it has individual motors per cylinder. I think that'd be a little bit complex, but we can see how it just has that, turns that one shaft, allows them to open further or less. So now that we know the basics of the variable valve timing and variable valve lift systems, let's talk about problems. And probably the most common codes you will get when it's related to this is a P0011 or a P0020. And they can have slightly different definitions. It's just intake camshaft bank 1, intake camshaft bank 2, and then there's also 12 and 23, I believe it is, for the other side, or 12 and 21 for the other side. So if it's intake or exhaust. Anyways, so usually, not always, but usually these codes can be caused by oil pressure. If I don't have proper oil pressure, usually the first thing, after a while, you will just know what to work on a car when it comes with a problem, right? So usually when you do this, first thing you want to do is check the oil. Make sure the customers change their oil, because they're not that great at changing their oil. I'll tell you, I'm not really either. And I can tell when my car is low on oil because it drives differently, because the variable valve timing system works differently with lower oil pressure. It doesn't work all the time. So sometimes you get a little bit of a buck, a little bit of a drivability problem. That's when you know it's time to check and change your oil. Also, oil consumption on these newer vehicles can be a problem. If we think about when they went to 0W20, around about 2010s for most manufacturers, way less friction, so it allows it to have less of that loss with the friction loss. But also, it's very, very thin, and oil consumption has become a problem as well. I know a lot of vehicles have oil consumption problems. Subaru for sure. If I just use that as an example, since I used to work there, according to Subaru, oil consumption of a quart in 1,000 miles is okay. That's normal. That's supposed to happen. In my mind, that seems a little excessive, especially since it is about a 6-quart oil pan on this car. And it was at the time a 7,500 mile oil change interval. So that means, but if I do the math right, that means I have negative 1.5 quarts in my pan when it comes time to change my oil at a normal interval. So that doesn't work. So after a while, you get down to like a quart in a pan, that car is not going to run right. And there's lots of other reasons you can have oil problems. And we'll talk about another one in a minute when we go live on the tool. But another reason we might have low oil pressure at the gear itself is because of clogged or dirty passages. Remember how I talked about that oil screen inside the banjo bolt? And then right here, this car is very, very worn out. So this is on one of those spool valves there. So there's where the oil goes into the spool valve, and then there's my 2 drains for the spool valve. And a lot of oil in there. I mean, not a lot of oil in there, a lot of debris in that oil. So this one probably has a mechanical issue inside the engine as well, and that would cause that problem too. So you got to clean the whole thing out, probably need to replace bearings, maybe even need to replace the whole engine. Who knows? Just kind of depends on the engine, but we don't want to see that sparkly stuff inside the engine, of course, right? So a lot of engine glitter there. So that's not a good thing either. And that's probably one of the more common problems you're going to run into. Yeah, you can have electrical problems, but the most common are usually going to be oil and maintenance related to the vehicle itself. And then it could cause a drivability problem, probably going to cause a check engine light, and it'll give you those. All right, so that's our basics. It's kind of quick on the slides tonight because there's not a lot of components. We're going to go through, do something a little bit different, I guess you could say. We don't usually do a full-on walk-through case study when we do these classes, but hey, we got some time today, so that's what we're going to do. So this is we'll call it a recreation of a real-world case study that we ran into in a shop one time. So this was on a 2008 Ford F-150. Had a complaint of, didn't drive quite right, drivability problem, engine drivability problem, and the engine light was on. So, of course, what's the first thing we want to do? Anytime a vehicle comes in, engine light or not, doesn't matter. We want to go into our scanner and we want to scan the whole vehicle. So we want to be able to get a health check on that car and see what is the problem. Are there codes in other modules that we're not looking at either? So let's go into code scan. And then let's do a pre-scan. So it asks you pre-scan or post-scan. Am I doing it before I work or after all the work's done? So we'll do a pre-scan. It says ignition on, engine not running, continue. And then it'll just cycle through all the different modules and tell us what's going on. So in this case, we come up with a P0022, which we did on that real world car. And that is intake camshaft position timing over retarded on bank 2. All right, so now what do we do? So we need to go through our diagnostic workflow on this. So since this is on a Zeus, makes it nice and easy. We can go into diagnose, and it'll bring us into our Fast Track Intelligent Diagnostics page. Now, Fast Track Intelligent Diagnostics, for those of you who don't know what this is, or maybe you haven't seen this yet, or maybe you have, but what this is this is a nice repeatable workflow that takes all the information you need to help you diagnose this vehicle, brings it all into one place so I don't have to be rooting around and finding things. And then it also automates a lot of the functions that you would probably normally do anyways in the midst of diagnosing a car. So it's meant to be used like a book, top to bottom, left to right. Just kind of read through the whole page and that'll tell us what's going on. So we have our code at the top. First thing we want to do in any diagnostic procedure is we want to check TSBs. Is there something out there that the manufacturer found that will solve my problem without having to go too much further? In this case, no TSBs. Now, that's not necessarily a bad thing. That means A, the manufacturer hasn't really found a quick fix for this. That's okay. But having no TSBs and knowing with one click that there aren't any TSBs, that saves me the time of going to whatever information provider I use for TSBs and looking for TSBs that I'm not going to find. So how much time would that take me? It could take me a couple of minutes, could take me a few more minutes if I think, well, there really should be something in here. I'm going to search through a bunch of different search terms. No, we don't need anything for this code because there aren't any. So that saves time right off the bat, just at a glance. Next thing, top to bottom, left to right, is going to be our top repairs graph. So what this is a lot of misconceptions and confusion as to what this is as well. So this is based on real world repairs over a 200,000 mile span. That's as far as we go right now, but it's based on a database of over 2.1 billion real world repairs. What was the most common repair to fix this code on this vehicle at what mileage? So we see the vertical is our number of occurrences, and then the bottom is the mileage. So it looks like at 150,000 miles, the peak number of occurrences was 320 times at the very top, and that was replace the variable valve timing control solenoid. 1,200 times total over the whole course of this 200,000 miles. That's what that number means. So this number means how many occurrences. This number over here means total over the whole course. So we can see in this case, yeah, it's pointing us in a pretty big direction. It says replace variable valve timing control solenoid. Now, I'm not going to tell you that that's what we want to do because we want to do more investigating first. We don't just want a parts shotgun at this. But it gives me an idea. And this is based off of what was on the repair out of the 2.1 billion repair orders, how many thousands of repair orders on an 08 Ford F-150 with a P0022, what was on the repair order. So in this case, valve timing solenoid, camshaft sensor, solenoid seal. So there was a seal on there, timing actuator, engine assembly in that case, oh boy. And then engine timing cover seal. So in order to get to some of this stuff, maybe you have to remove the timing cover. So you need to have a seal there. So it's going to be related items and what were the most common things that other people have done in the real world in order to fix this problem. Right? So it sounds like it's going to save me some time over some other things that we might be able to use for that. Next one on the list is going to be data. So we call it smart data. And what this does is just like that, in 1 or 2 clicks, depends on the vehicle, but in 1 or 2 clicks, it filters down the list of PIDs just to related PIDs that we need to look at for this problem. It also sets known good and bad values on some PIDs, if we see the flags here. When you see a flag, in this case, the blue outline flag, this means that it's being monitored, but it hasn't gone outside known minimum max parameters. So it's within spec where it should be. And by the way, it should only be used with the vehicle is idling at operating temperature with no loads. So that's what we have the data for. So we're sitting here at idle, and don't pay attention to the data switching. It's just on a demonstration vehicle, so it's not real live data. But we do get the different flags. So we get the blue flag means it's being monitored. Red flag means it's out of spec. So in this case, intake air temperature is 253 degrees. That's pretty hot. Or we have a spark advance there, or we have a variable cam timing advance. So in this case, doing this is not good. It's out of spec, whatever way it went. Now, if we'd have to go back a little ways to see where it tripped, right at the very beginning is where that went out of spec. What we can see over here, and we can compare it to the other one, which is flat. So in this case, it looks like I need to look at that side. Now, I know it's the opposite side too, but once again, it's demo data. So it's not necessarily real world numbers, but it's the process is what we're going through. So in this case, it's out of spec. This side's not out of spec. So then we would want to investigate on this. Now, another thing that we get asked a lot, and there's another common question about this, is when we do this, how many PIDs do we take out of here? How many PIDs do we take out? So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 21. 21 different PIDs on this screen. So few PIDs, I don't even need to scroll. I can't scroll. They don't go off the screen. It's just, here's your 21 PIDs. How many PIDs are there available? So if we go into custom, we can customize this list further, or we can see what data is in here. So in this case, it looks like there's stuff on engine data, fault data, etc. All of these bolded categories are where we have PIDs. So if I open that up, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 PIDs out of this list of, I'm not even going to count, there's so many. Now, why do we do this? Well, if I'm diagnosing a vehicle and I have a problem with the cam timing, do I care if what my brake pedal position sensor is doing? Do I care what my generator is doing? Do I care what the master key? No, I really don't care about all that stuff. I can leave that off to the side. I don't have to scroll through lists and lists and lists of PIDs. I can just look at the pertinent PIDs that make sense to this vehicle based on, this is over 200 billion real world scanner events. So there's a lot of information that this is based on. And you could do it manually if you wanted to. You can do it manually with any other tool, if you any of our other tools anyways, if you wanted to. But how long is that going to take you? Go through the list, search through the list, find, oh, there's RPM. Check that one off. Cylinder head temperature. Let's check that one off. Spark advance. Check that one off. It's going to take you a long time. How long did this take? Seconds. All right. So it's a huge time saver with this. So we know we need to look at that variable cam timing. We back up a few. Next thing we can do is go down to functional tests and resets. So now that we know data and data's pointing us in a direction, now we want to go to functional tests. So if I go into functional tests for this code, there aren't any pertinent functional tests. That's fine. In this case, we could go to the main functional test list and pull any off of that if we really wanted to. But in this case, we don't have anything we need for this code. Go down a smidge further, we get our guided component test meter. So if you have a tool with a scope, a snap-on tool with a scope, you will have guided component tests. It is a database of over 5 million different tests. There's a lot of different tests that we could do. It's going to filter out and sort out just the ones that pertain to this problem. So crank sensor, cam sensor, ECM, variable valve timing. So we go into variable valve timing, we go into component information, and it is going to tell us about the different solenoids. So variable valve timing solenoids are used to control the variable intake cam timing. Solenoids are controlled by the ECM to open and close oil shuttle valves, or those spool valves. Shuttle valves direct oil to valve timing units. When the oil pressure overcomes return springs, the cams move to the advanced position. So in this case, this has the return spring that defaults it to full retard and then adds oil to advance. Best test location is at the black component connector itself, and test at the connector on top front side of each valve covers. Sounds like it's easy to get to. Solenoid 1, solenoid 2. And if we go down a little bit further, it gives us some more information if it had extra. How about some notes? When the valve timing is in retarded mode, the ECM periodically energizes the solenoids to provide a spurt of oil into the valve timing units. That's interesting. The ECM sends this lubrication pulse once every 5 minutes. So since there's no oil flowing in it, if it's in full retarded mode, that means just the spring is pulling it back. It needs some lubrication. So in order to lubricate, shoots a little squirt of oil in there every 5 minutes. Note that it may be audible at idle with the hood open. So that's good to know. So don't worry if you hear a clicking noise under the hood, that is normal while it's idling. So I thought that was kind of an interesting little note. Interesting little note. Then we have a voltage test, we have a resistance test, and we have a signature test in here as well. So it's going to tell us where to hook up our test leads. It's going to give us our pinouts, and once again. And then if it's a signature test, it's going to show us, okay, here's what it would look like turning it on, turning it off, turning it on, turning it off. So we would test this solenoid. In the case of this, the solenoids would test good. In this particular case, the solenoid tests good. We go down here a little bit further. In this case, it says it tested the variable timing solenoid. So found out they didn't match. Next thing is going to be additional real fixes. So there's hundreds of additional real, or just thousands overall of real fixes. But it's going to rank them by how many times this is a confirmed fix. So a lot of times it's the solenoids, right? Cam position sensors in there. We also have code combinations with symptoms as well. And then we get down to that. Cam position sensor. Here's for oil and oil filter in this case. That's curious. Remember how we talked about that P0022 was for, could be an oil problem. Next thing, since this is an 08, we can go and get some troubleshooter information as well. And we have this one on right here, intermittent rough idle and engine noise. Click on that. Let's see, check engine light may or may not be on. Possible codes 0012 or 0022, or misfire codes from multiple cylinders. Customer may complain of having intermittent rough running at idle. When the event occurs at idle, raising engine RPM may change engine noise and roughness. Vehicle mileage may be as low as 30,000. Recommend driving vehicle while monitoring oil pressure. Lack of normal oil pressure may be an intermittent concern. Usually occurs on a return to idle after reaching normal operating engine temperature. Oil pressure drops to 15 psi or lower when engine roughness and noise occurs. Raising engine RPM changes roughness and engine noise. Correct oil pressure keeps cam phasers advanced based on command from PCM. The lack of oil pressure can cause the cam phasers to retard, causing the running problem and setting various codes. So if I don't have enough oil pressure, I can't overcome the spring tension, and I can't advance the timing. Cam phasers may be part of the problem. The cause is the lack of oil pressure. Diagnostic aids. Verify lack of oil pressure. Inspect camshaft caps for excessive scoring. The timing cover and valve cover is off. Remove oil pressure sender and install adapter and put pressurized oil through the system while looking for leakage. Heads have plug on firewall side just above the freeze plug. So in this case, could be an oil pressure issue. And in the case of this real world case study we're talking about, that was the issue. So they were only getting 14 PSI on this vehicle when they checked the oil pressure. And thanks to a troubleshooter tip, they found that. So where was the problem? Because the vehicle did not have low oil, which is the most common problem, right? If you have low oil, you have low oil pressure. Did not have low oil. The oil was okay. So next thing we need to do is we need to figure out, well, if we only got 14 PSI, what's it supposed to be? So in this case, I have, as I said, a Zeus. So I can link my shop key account to this. So I'm going to go to repair information, and it's going to log me in. So it's going to log me into the site. It's going to log the vehicle in, and it's also going to do a search for the code. All seamless. Don't have to worry about it. Doing it right now. So there's my P0022. I could go in here and do a search for this. So if I want to do search results, I can see all my information all on one screen. Once again, very similar to how Fast Track Intelligent Diagnostics does it. Gives us all that information there. But in this case, I just want to look at the specs. So we're going to go to common specs over here on the right-hand side. And this is going to give me my oil pressure. So we're going to come down here a little bit. Engine mechanical, 5.4 liter. Oil pressure hot at 2,000 RPM, 40 to 75 PSI. So if I'm only getting 14 PSI at that case, should be 40 to 75. Yeah, those oil control valves are not going to work at all. So in that case, yeah, that's definitely a problem. So what happened on this truck? Not to leave you in suspense. So we had the code. Oil was good. Oil control valves were good. Low oil pressure. Come to find out, after they examined the engine a little bit further, after they found the low oil pressure issue, ended up being a bad cam seal. So the cam seal is allowing the pressure to bleed down, and just basically just dumps it right back into the chain bath at that point. So didn't have enough pressure to actuate those solenoids. So in that case, that was the problem. So sometimes it's not electrical. Sometimes it's that, let's look back at basics. Do I have oil pressure? Do I have fuel pressure? Do I have, what have you? Sometimes you need to look back at that. In that case, you need to look at those basics. So I just thought that was kind of a different one. Right? It's a different story. So it was a bad cam seal that caused the oil pressure to drop, which caused the code and a drivability problem on a vehicle, all just from low oil pressure. All right, so we got one more little thing I want to walk you through here as well. So let's walk through one more guided component test here. I'm going to pull up my BMW because the BMW demo board that we have uses a BMW that has all of these types of systems on here. So if I go into engine, we can see we have the Vano solenoid. So that is our variable valve timing. And then we also have variable intake on this. And we also have Valvetronic on this car. So it has variable valve lift and it has variable valve timing. So I'm going to go to the intake Vano solenoid, which would be our variable valve timing. It's going to give us component information here. Solenoid operates by controlling the amount of engine oil between two chambers in the camshaft adjustment unit. What do you know? Just like we were talking about. By creating higher pressure in one chamber than the other, the adjustment unit will extend or contract depending on which chamber pressure is greater. Camshaft timing is typically slightly retarded at idle for improved emissions and idle quality. During acceleration, the camshaft is advanced to enhance the efficiency of combustion. Intake camshaft control solenoid is ground controlled by the ECM in this case. It is used to modify intake cam timing by directing oil flow through the Vanos unit to advance the intake camshaft. This will provide an improved torque curve at idle. The solenoid is de-energized. This maintains a retarded intake camshaft position, so it's full off. The intake and exhaust Vanos solenoid valves are mounted to the front of the cylinder head. The intake solenoid valve is the one on the top. The exhaust solenoid valve is the one at the bottom. May be difficult to access the solenoid, so we also give you pinouts for the ECM there as well. Tech notes: if oil temperature is extremely hot, above 212 degrees, the DME deactivates the camshaft control solenoid. The oil temp sensor is a vital input for the Vanos, so if we don't have the oil temp sensor working, we also will not have that working. In this case, if the DME detects oil temperature sensor fault, ECT will serve as a backup sensor. Intake Vanos solenoid can be swapped with the exhaust Vanos solenoid for diagnostic purposes, so that's like dealership diagnostics. Swap it over and see if it works, right? The problem moves with the solenoid, then you'll know the solenoid is at fault. Also, if you test the solenoid, you'll know if it's at fault too, and you want to take it all apart. Be careful not to mix up the electrical connectors for the solenoids, or this can lead to misdiagnosis or other problems. Apparently, they're the same color, and they're really close to each other, and they're the same number of pins. So thank BMW for that one. So don't mix them up. Harness side back probing at the component. So if we back up, and we could do a resistance test, a signature test, or a duty cycle test. So let's look at duty cycle. So we're going to go to the valve over here, the control signal, and it's a duty cycle signal. While snapping the throttle, duty cycle will change as the Vanos solenoid on time is varied. The duty cycle will change with increase of engine RPM, load, and or engine temperature. Hit view meter. After we're hooked up, it's going to click, it's going to buzz, and then it sets up the voltage or whatever measurement. In this case, we're measuring duty cycle percent. And then it gives me a time down here, sets it all up for me so I don't have to figure out what those are, and I don't have to do it. So in this case, we're looking at 35% duty cycle. So that means 35% of the time it's on, and then the other 65% of the time it is off. So if we increase the duty cycle, though, oh, that's the wrong way. So there's 0 duty cycle, so that's off. And then we have, let's say, go up to like 50% duty, and then up to like 95% duty or so, 92% duty. So you can see how it changes. And this is what the graph will look like. So it's just doing a graphical representation of the percent on time of this particular item, which is a pulse width modulated duty cycle signal. So that's just one way to test it. Multiple other ways to test it, as we saw in there as well. We could check the resistance as well. So it should be about 8 to 14 ohms on the resistance. But once again, could be hard to get to it as well. So a lot of different ways to test out the system. A lot of information already built into the tool with that as well. If you have one of the tools with the guided component test, the information is definitely out there, and they all pretty much work roughly the same. There's a few little idiosyncrasies here and there, but by and large, variable valve timing system, not a ton of components, and it's going to work. It's either going to work or it's not going to work, really, is what it boils down to. And they're going to work very similarly to each other. All right, so let's go and talk about, that's my material for this week. Let's talk about next week. Next week is our hybrid vehicle component and testing class. So we're not, we're starting to talk about the non-internal combustion engine cars. Well, of course, it does have an internal combustion engine on a hybrid, but it also has an electric car in there too. So we're going to talk about hybrid vehicle components and testing. And oh yeah, by the way, a couple weeks after that, we will be doing an electric vehicle class as well, just so you're aware. But next week for sure, hybrid vehicle component and testing, same time and same place. If you want to register and join on Zoom, 6 and 9 Eastern, 5 and 8 Central, go to snapon.com/OT. You can watch live on Zoom, ask questions there. Or if you prefer YouTube, you can go to youtube.com/Snap-on Diagnostics, all one word. And make sure if you are on YouTube watching, please subscribe to the video. Definitely helps us out a lot with that. I know I actually did a presentation with the CEO about this stuff, and the subscribers, they like that. So if you can subscribe, ring the bell, give it a like, all those good things. It's definitely very appreciated. Helps me out for sure, and helps out us Snap-on Diagnostics as well. But like and subscribe there. you want to see any of our past topics, they are all archived on YouTube as well. So if you go to youtube.com/snap-on-diagnostics, there is a playlist for all of these past classes here, 37 different episodes, anything from ADOS, data bus testing, component testing, HVAC, all of these different things we talk about. And they're all about that 30 to 40 minute range, just like this one was. Very similar format to all of them. And you can just see the different topics and check them out at your leisure. They are all 100% free. Gotta love that too. I always say if it's free or if it's for me. All right. So we'll get to questions here. I see I got a couple on both sides of the fence, but make sure you talk about my buddy Al here as well. So Al also does free training for Snap-on Diagnostics. He does tool-specific training. So on Monday, it's on Apollo, Wednesday is on Zeus, and Thursday is on Triton. So for these classes, what it is really designed to have you have the tool in front of you and follow along with Al on his screen as he's walking through this, the different functions of the tool. So the first hour is pretty much the same thing, just on whatever specific tool. So it's going to be, let's set up your Wi-Fi. Let's set up your free Snap-on Cloud account. Make sure you have that so you can make sure you can share your files with your customers. Also go through code to completion, all the way through Fast Track Intelligent Diagnostics. How can it help me as a technician diagnose cars easier and faster? So that's the first hour on any of them, just on their respective tool. Then on Wednesday and Thursday, since Zeus and Triton have test meters in there, it's going to take a 5-minute break, and then another hour on guided component tests, lab scope, different functions of those, different real-world scenarios on those, different tests that you can do with that. So it is a very comprehensive class. Al is a deep wealth of knowledge with Snap-on Diagnostics. He's been around for a very long time with the company, came over before Snap-on Diagnostics with Snap-on Diagnostics. So he's been with us a long time, definitely worth your time there. All right, so let's get to questions. Got one on Zoom here. Let's see. Jesse says, thanks for your time. Thank you for your time. I appreciate that. Definitely appreciate you chiming in there. Thanks for your comment. Let's see, and I got to scroll up on YouTube here. Let's see, Abel's checking in. Hi again, Abel. Dusty's Auto Repair, welcome. London Boss, thank you very much. Let's see, hello from Apocalypse 2011. Let's see, Nick, hello. Everyone from around the globe, yes, definitely for that. It's a wonderful thing to see everybody checking in from around the globe. I know you're from the UK, it's pretty late over there, but definitely appreciate that. Let's see, Apocalypse is from Brazil. So thank you. Welcome for that. Motorcycle diagnosis. Hey, good question there. And we will be doing a motorcycle class in about 6 weeks or so. One of these classes will be on motorcycles as well. So definitely good with that. Soren checking in from Birmingham, UK, not Birmingham, Alabama. Welcome. Brett checking in from Kansas. Welcome. Raymond, thank you for appreciate you joining us there. Let's see, and Soren has a question. Let's see, thanks very much. I have a question. Recently had an Audi RS5 4.2 engine V8 vehicle was misfired, bank one, which, and now I don't see the rest of the question. Soren, not really sure what the rest of the question is. I just see you do have a Audi RS5 with a misfire. Bank one, not sure how I could help you out further without the rest of that. So maybe you can comment a little bit further there. Maybe you got kicked offline. I'm not really sure. But hey, you can definitely leave a comment on the video if we end the live before you get that up there. And Sal, welcome as well. So with that, let's see. Andrew asks, when we doing scope waveform recording, where can we find record? Well, Andrew, that's a good question. So when you are in the scope, it automatically records. As soon as you go in there, automatically starts recording until you hit the stop button. That's why you'll never see a record button unless you hit the stop or the pause, because it automatically just, as soon as I'm in there, I'm recording. We don't want you to miss anything, because wouldn't it be wonderful or wouldn't it be awful if you hooked up and you went into the scope and it wasn't recording and then you had a glitch? And then, oh man, I didn't hit record. So it automatically records. Good thing, automatically records there. So yeah, you don't have to worry about that. Automatically records. And then at the top of the screen, you'll have a save button up there as well. So you can go there and save it, play it back later. All right, got a couple more coming in on YouTube. Sal says hi. Dusty says, love the description of the Vanos and the Valvetronic system. Good for that. Oh, Soren said the exhaust camshaft seized, I guess, in that case. So that's not a good thing with that. So yeah, I guess that caused a misfire. Let's see. Dusty also asked, my question is, what is your least favorite variable valve timing variable valve lift system? And if you have time, why? I don't know if you just kind of to work on. I would imagine that Valvetronic system is not too fun to work on. That's not really a joy. Anything on a BMW is not really a joy, anyways. It's kind of hard to get to. I will say VTEC was pretty easy. Subaru seemed pretty easy as well. We rebuilt a lot of heads at Subaru with those systems in there. So they're pretty easy, other than the cam sprockets. I would say I hate the cam sprockets on Subaru, the plastic cam sprockets. And they're always way over torqued from the factory. So you took 3 people to get those cam bolts out. And sometimes they'd strip out those cam bolts too on the inside because they were Allen wrenches, Allen wrench sockets. So they would round off. It was terrible. You'd break those cam gears, no problem on some of those. So I will say for that, there's at least get a really high up on the chart of my least favorite thing to work on. The system itself wasn't bad, but it was just, if I had to do any repair and had to get that cam gear off, you snap the cam gear in half. It's just a nightmare, just a nightmare. So I'll give that one definitely a good mention there. Miguel, hello from Kansas City. Brian, glad you liked it. And Eric, thank you for checking in from Texas. Let's see. Enjoying all these free training, helps out with using my old Verus Pro. Yeah, definitely great tool. Don't support the software on that anymore, but it's still a really great scope as it stands anyways, and you can still communicate with cars as well. So you lose access to a few things, but hey, you still have it, and hey, it could always be a time for a Zeus, right? Let's see. Jesse, you could ask questions about your own truck, but we are running kind of short on time right now. So if you want to type it in real quick and kind of related, we might be able to help you out. The other thing I like about this live thing is we can always help each other out as well. So if we're doing live chat on YouTube, I see sometimes people answer questions there. And on here, if you use the chat, you could do that too. We might run out of time here before you get that question typed in. Soren says, thank you very much. Thank you very much. Yeah, you can leave your question in the comment below after the video, or I think you can actually live comment on the video without actually live chatting. Well, so yeah, I do check those comments on occasion. Let's see. Okay, perfect, Jesse. So yeah, ask away next week. That'll be perfectly fine, and we'll have more time to get to it then. So with that, I think we got everybody today. All right, cool, Soren. I will look for that comment probably tomorrow morning by the time I get around to it, but I will definitely make sure to check that. So with that, thank you very much. I appreciate everyone taking time out of their busy day, busy schedule, come spend a little bit of time with us. Hopefully we learned a few tips and tricks on the variable valve timing and the variable valve lift system. Hopefully you can join me next week for hybrid vehicles. With that, enjoy the rest of your week. Enjoy your weekend and take care.